My goal in having you complete this construction was so that you would discover the properties of a mid-segment of a triangle and a mid-segment of a trapezoid. As you can see, I have a variety of markings within this picture. You can see in blue and in red the construction of the midpoints of side AB and side AC, and they are labeled as X and Y respectively. So once I constructed the midpoint, I drew segment XY so that I could take a look at the properties. The first bullet asked you to compare segment XY with segment BC and then state the relationship between their lengths. So as you can see with the green markings that I'm highlighting, I first took and measured segment XY. And then below on BC, I was trying to determine how many lengths of XY made up the length of BC. And what I discovered is that XY is half the length of BC. Or another way to write this is that 2 times the length of XY is equal to the length of BC. And the next bullet asks you to compare angle AXY to angle ABC and state the relationship between the measures of those angles. So now in purple, you can see that I went ahead and I started by making my arcs along ABC and angle AXY. And then I measured the width of the angle, just as if I was constructing a line parallel. I would construct or copy this angle above, angle ABC above at point X and construct angle AXY. But in just using the tool, I discovered once I made the 2 arcs, which were the same size and opening it up to their width, that the width was exactly the same. So this marking right here. So in doing that, I discovered that the measure of these 2 angles was equivalent. So the measure of angle AXY is equal to the measure of angle ABC. So then the next bullet asks, in using your discovery from above about these 2 angles and their measures, what is the relationship between segment XY and segment BC? Well, since those 2 angle measures are equal, those 2 angles are congruent, and I can then state that these 2 segments, XY and BC, are parallel. This is because if 2, and you can feel free to write this down, if 2 lines cut by a transversal form congruent corresponding angles, then the lines are parallel. So I can go back up into my picture. Because those 2 angle measures are congruent, I can now state that these 2 set line segments are parallel. Now because these 2 triangles also, again, they're overlapping triangles, they share angle A in common as well, I can then answer the last bullet that asks you to compare triangle AXY with triangle ABC. What is the relationship between these 2 triangles? These 2 triangles are therefore similar by the angle-angle similarity postulate. And now let's take a look at the trapezoid. As you can see on the trapezoid as well, I've already gone ahead and constructed the midpoint of sides AB and CD, and I connected the line, I drew the line connecting the 2 midpoints, which is XY. Down at the bottom, what I first did was, in looking to answer the first bullet, which said to compare segment AD, XY, and BC, and what is the relationship between their lengths, I went ahead and extended this side of the trapezoid, and I did that so that I could add the length of AD down below, you can see I have this marking right here to indicate that I measured that, and then you can see underneath the orange that I copied the segment down below, so that the length from here to here, if I call this point, let's do that in red, if I call that point FC, all the way from F to C represents the length of BC plus AD. So then what I did next in orange is I measured the length of XY, and then I went down and I copied that segment on FC, and then I determined that it was two lengths, again, that fit right to the length of FC. So to answer the first question, compare the segments and then what is the relationship? XY is equal to half the sum of AD in BC. And again, another way of writing this without the 1/2 is I can say that 2 times XY is equal to AD plus BC. Next, again, it wanted me to analyze the relationship between the angles, and I did the same thing that I did on the front. I went and I made the arcs with my vertex at B and then the vertex at X. So I first made this marking, and then I made this marking, and then I measured the width of each, and I discovered that the width of each of those angles was exactly the same. Therefore, the angles are congruent. So to answer the question, what's the relationship? These angles are also congruent, so their measures are equivalent. Using the discovery above, again, if these two angles are congruent, therefore I can say that XY is parallel to BC. Again, if two lines cut by a transversal form congruent corresponding angles, then the lines are parallel. Now, because this is a trapezoid, and I already know that BC is parallel to AD, and now I know that AY, or XY rather, is parallel, I'll make 2, is parallel to BC. I also know that XY is also parallel by the transitive property to AD. So, and then therefore, XY is parallel to AD. The next question wanted you to, so given that the relationship between XY and BC, given that all these segments are parallel, again, think of all the parallel line properties from the unit previously in the year. If these lines are now parallel and they're cut by these transversals, then angle BXY, this angle right here, is going to be congruent to XAD. And then ADY, this angle right here, is going to be congruent to XYC, this angle right here. And then lastly, this angle right here is going to be congruent to this angle right here. So all of these angles, or angle pairs, are going to be congruent. So this angle pair is congruent, and the last angle pair is congruent. And then we have the 1:2 ratio between the two sides. So since all corresponding angles are congruent and corresponding sides are proportional, we have these two trapezoids as they are similar.